In this video, we're going to be going over how to use the debugger in your IDE and a couple different instances on when you might want to use it. I'll be using Visual Studio during this, but if you have another IDE that you're using, you should be able to follow along just fine. So we have this example code, and here you can see we have a while loop. And this while loop is going to iterate a few times and output whatever the counter is equal to. And then it should break and see out another statement and then return. So this code has a bug in it. Hopefully looking at it, you should be able to tell just at first glance what the issue is. But let's just run the code and see what happens. So we're expecting this to only run a few times, see out before the loop and see out after loop. So we'll run this. And as we can see, we are stuck in an infinite loop. This is going on forever. So let's run that. And so now what do? Hopefully you would guess that it's something to do with this, and you can tell that, oh, this statement is clearly not ever true because it's not exiting. But let's say you don't know any of that stuff. Let's set a breakpoint. So we click over here and we set a breakpoint. And then we run the code. So we run, and instead of executing, the code stops where we set our breakpoint. So it stopped on this line that said see out before the loop. There's a couple controls you'll want to use. They'll be up here. The one that you'll mainly use is, the one you'll mainly use is step over. And when you click that, it's going to move to the next line. And then down here, you can see the variables that are active so far in the program. Right now, it's just argc and argv, which we passed in up here. We're not going to worry about that for this bug, so we'll just ignore those. So if we step over, we should be able to see we have now see out before the loop. So that's good. Now we can see counter. We're initializing it. Right now it just has some junk value, but if we go to the next line, it should be initialized to 0. When the value here is red, that means that the previous line of code changed the value in memory of what this was. It's something that can be useful to know. So here we're at the while loop now. While the counter does not equal 9, we can see that counter is equal to 0. It is not equal to 9, so we can see exactly what it equals right now. So we can step over, and we can see that there's a cout statement. If we go to here, we should see, yep, we see out counter equals 0. And then the line we're on now, we can see from this arrow, is counter plus equals 2. So if we step over, now counter is equal to 2. And you can see that the value just barely changed. So that's good. Now let's step over again. The shortcut for that is F10. So if we click F10, it should step over. Perfect. So 2, that's still not equal to 9. So we're going to keep going, increment to 4. This should all make sense. We're just going to keep going. Now when we increment, counter is now equal to 10. And if we look right here, 10 does not equal 9. So this loop is going to just keep going indefinitely, as we can see here. It should have stopped. What we wanted to is we didn't want to go past 10. So now let's stop our, let's stop our debugging. And there's a couple solutions you could do here to fix this. I'm just going to change this to be, well, counter is not less than or equal to 9. And let's run it in the debugger again, just to make sure that worked. This should, but we'll just double check. So if we step over a few times, counter is 0, now it's 2, 4, 6, 8, and 10. So now counter is 10, which is not less than or equal to 9, which makes this statement false. So our while loop should break, and it does. And we output after the loop. That's it. So in this example, we're going to go over what it looks like when you get a segmentation fault. This is going to happen to a lot while programming. And this example is a little more complicated than the last one. If you haven't gotten to the linked list portion of the class, a lot of this isn't going to make sense. And that's totally okay. The concept is really what's important here. And once you cover linked list, you can come back to this video and hopefully you'll understand more of what's going on here. But essentially what we're doing is I'm just creating a list, and I'm just putting 5 different nodes in there, or 6, maybe 6 different nodes. Anyways, I'm putting a number of nodes in this list, and this is actually what's causing the bug. I'm doing this on purpose so we can see it happen, but let's say you didn't know what was going on in your code. You didn't know that this line was causing a bug. And then we'll continue on and essentially try to output everything in this list and then return 0. So if we run this, we'll see that we get a segmentation fault. That's what this is. A segmentation fault is something that happens, it's also might be known as a runtime error. It's something that happens as you're running the code, and it gets something that the compiler has no idea what to do with. And if we look, we can see in the output here, we outputted the first handful of nodes, and then this last one, when we tried to output, it was some weird value that does not look like anything that we would have put in here. And then it broke. It didn't finish. So we'll stop this, and we will use a debugger again. I know that this stuff all works, and this is all essentially just set up so I can get this bug to even happen. So let's set a breakpoint here and run it. And we'll just step through. So as we step through, I'm creating a new node. I'm setting the previous nodes next to this new node that we created, and then I'm incrementing our temporary node over. Again, it's totally okay if that part doesn't make sense at all. It's not really important. This is how linked lists work, but you don't really need to worry about that right now. So we're going through and everything seems to be added okay. And then we get to the end, and temp is still pointing to a spot in memory. It's pointing to this spot in memory, which just so happens to be the very last node in our list. And we're deleting that part of the list. So now, essentially, we have a list that the last node is uninitialized. And if your compiler tries to read uninitialized data from memory, it's going to run into an error. So we can see if we're going through and outputting, our iterator is going to the right spots in code, in memory rather. You can see it's outputting these, and if we keep stepping through, we'll see that that one worked okay, and I believe that one will work okay too. Yes, and we can see that if we look at iter, if we open this up, we can see this data is not initialized, and it's next. It has no next. It does not know what that is. So when we step over, it does output because this here is just some uninitialized value that was stored. But when you try to access a pointer that is not initialized, then you'll get a segmentation fault when we try to access the data of an uninitialized pointer. And we get a break here. So by single stepping through, we can realize, okay, everything worked except for the very last node. So let me figure out what that issue is. And here we would realize, oh, my last node is no longer initialized. So we can get rid of that. And if we get rid of the breakpoint and run it, it should now run to completion, and it did. So now we can see output all 6 of our nodes. So again, this might not make sense if you're near the beginning of the semester still, just because of the way that pointers and linked lists work. But hopefully once you get to that point, you'll understand exactly what causes segmentation faults and how you can easily figure out where they come from by using your debugger. So that should at least give you the basics of learning how to use the debugger, and you hopefully should be able to now go through and debug problems that you have on your own. As always, if you can't solve a problem, feel free to hop onto the help queue, and us TAs will be more than happy to help you out.